we now discuss the solution of a problem from the section Differential Equations. This question is related to linear differential equations, and this question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, let y is equal to y of x be the solution of the differential equation. This is the differential equation given, where x belongs to the open interval 0 to pi by 2 with the value of y at pi by 4 is equal to pi square by 32. If the value of y at pi by 3 is pi square by 18 multiplied by e power tan inverse alpha, then the value of 3 alpha square is equal to. So we are given y is equal to y of x is a solution of this differential equation with the initial condition y at pi by 4 is equal to pi square by 32. If the value of y at pi by 3 is equal to pi square by 18 into e power tan inverse alpha, required to find the value of 3 alpha square. Let's now discuss the given problem. Let's now discuss the solution of the given problem in detail. We are given a differential equation. This is the differential equation equipped with an initial condition. So a differential equation equipped with an initial condition is called an initial value problem. Here, this is the differential equation and this is the initial condition. Let's look at the given differential equation. It is of the form dy by dx plus p of x into y is equal to q of x, where p of x and q of x are functions of x. It is a first order linear differential equation in y. To solve such a differential equation, we first find its integrating factor. The integrating factor is given by e power integral p of x with respect to x. Now, after finding the integrating factor, we write down its general solution. The general solution is given by y into the integrating factor is equal to in the integral of q of x, that is the right hand side function, multiplied by the integrating factor, then integrate with respect to x plus c, where c is the constant of integration to be evaluated. Right. First of all, let's get into our question. Now, the integrating factor is e power integral p of x dx. Let's first of all evaluate integral p of x dx. That is equal to the integral p of x is here root 2 by 2 cos power 4 x minus cos 2x dx. Right. So for cos 2x, we have written here as 2 cos square x minus 1. Minus is before that. So minus 2 cos square x minus 1. The integral remains the same in the other parts. Agreed. Now, in the denominator, this 2 cos to the power of 4x, we have written as cos power 4x plus cos power 4x minus 2 cos square x minus into minus plus 1. Right. In the denominator, we see this one cos power 4x minus 2 cos square x plus 1 as 1 minus cos square x whole square. So cos to the power of 4x in the denominator plus 1 minus cos square x whole square. So let's look at the denominator only. That is equal to root 2 into integral of 1 by cos to the power of 4 plus 1 minus cos square x is sin square x whole square, that is sin to the power of 4x dx. Right. So we take sin to the power of 4x common in the denominator, then you will get root 2 into integral 1 by sin power 4x taken common. The cos power 4x by sin to the power of 4x is cot to the power of 4x plus 1 bracket close dx. We continue this in the next slide. So we have the integrating factor we have written, and we have taken in the denominator sin to the power of 4x. When taken in the denominator, it will be cos sin to the power of 4x into cot to the power of 4x plus 1. Right. 1 by sin to the power of 4x is cosecant to the power of 4x. We have written in the numerator by cot to the power of 4x plus 1 with respect to x, the integral multiplied by root 2. Ah, great. So how to integrate this one? So what we do is in the numerator cosec to the power of 4x we have written as cosec square x into cosec square x. For the first cosec square x we have written 1 plus cot square x, and now substitute cot x is equal to t, then differentiate minus cosecant square x dx is equal to dt. So this integral will become root 2 into integral 1 plus cot square x is 1 plus t square, that is t square plus 1 into cosecant square x dx is minus dt. So this minus is out, and dt in the denominator it is t to the power of 4x, t to the power of 4 plus 1. So this is the integral. Now we have divided both numerator and denominator by t square, that is minus root 2 into t square by t square 1 plus 1 by t square by t power 4 by t square plus 1 by t square dt. Agreed. This is the usual technique what we will be doing, and the denominator we will write as t minus 1 by t whole square plus 2, adjusting the terms. So this is minus root 2 integral 1 plus 1 by t square by t minus 1 by t whole square plus 2. So put t minus 1 by t as u and differentiate, you will get 1 plus 1 by t square brackets dt is equal to du. So this integral will become minus root 2 into integral du by u square plus 2, that plus 2 we have written as root 2 whole square. So this is minus root 2 integral, this is looking like dx by x square plus a square, and the integral dx by x square plus a square is 1 by a into tan inverse x by a. Applying that here, minus root 2 into minus 1 by a, that is 1 by root 2, tan inverse x by a, that is u by root 2. Root 2 cancels, we get minus tan inverse u by root 2, and that will be equal to minus tan inverse t minus 1 by t by root 2. Substitute for t cot x, then you will get minus tan inverse cot x minus 1 by cot x by root 2. Simplify this cot x minus 1 by cot x, you will get that as 2 cot 2x. This is 2 cot 2x you will get, and minus tan inverse 2 cot 2x by root 2. Now root 2 cancels, you will get minus tan inverse root 2 cot 2x. So that is your integral px dx, and the integrating factor is e power integral px dx, that is equal to e power minus tan inverse in brackets root 2 cot 2x. We continue in the next slide for the general solution. So that is the differential equation, this is your integrating factor. So, and the general solution is given by y into the integrating factor is equal to integral the right hand side function into the integrating factor, multiply and integrate with respect to x plus c. So the general solution is y into e power minus tan inverse root 2 cot 2x is equal to integral qx multiplied by the integrating factor. and luckily we see here e power tan inverse root 2 cot 2x into multiplied by the integrating factor e power minus tan inverse root 2 cot 2x, that will be 1. That will be 1. So that is equal to integral x dx plus c, where c is the constant of integration. Integral of x dx is x square by 2 plus c. Thus the general solution is y which is a function of x into the integrating factor is equal to x square by 2 plus c. To evaluate this c, we are given a condition. The value of y at pi by 4 is equal to pi square by 32. So in this x is equal to pi by 4, you substitute y into y of x is pi by 4, that is pi square by 32 into e to the power of tan inverse root 2 cot 2x. 2 into pi by 4 is pi by 2. Cot pi by 2 is 0. So e to the power of 0 you will get, and that is equal to pi by 4 whole square into 1 by 2, that is pi square by 32 plus c. So thus we get this is the condition. So we get this one. The value is pi square by 32 into e power 0 is equal to x square by 2, when x is equal to pi by 4 is pi square by 32 plus c, and pi square by 32 cancels, and you will get c is pi square by 32, send it there. So c will be 0. C will be 0. So when you substitute c is equal to 0 in the above general solution, we get a particular solution. So the c, in the place of c, we write 0. So the particular solution is y of x is equal to x square by 2 into, send this to the other side, e to the power of tan inverse root 2 cot 2x. We continue in the next slide. So the particular solution, we got it. Now it is given the value of y at pi by 3 is pi square by 18 into tan inverse alpha. You are asked to find the value of 3 alpha square. So in the above, substitute x is equal to pi by 3. So y at pi by 3 is equal to 1 by 2 into x square, that is pi by 3 whole square into e to the power of tan inverse root 2 into cot of 2 into pi by 3, 2 pi by 3. Right. And this when you simplify, it will be pi square by 18. So it will be pi square by 18 e to the power of tan inverse root 2 into cot 2 pi by 3 is 1 by root 3. So, and this is equal to pi square by 18 into e to the power of tan inverse alpha, and required to find the value of 3 alpha square. So equate pi square by 18 cancels, and e to the power of tan inverse root 2 by 3. So tan inverse under the square root of 2 by 3 is equal to tan inverse alpha. This will imply under alpha is equal to under the square root of 2 by 3 squaring, you get alpha square is equal to 2 by 3, that is equal to 3 alpha square is equal to 2. That is the required answer. The answer to this question is 2. Right. That is the detailed discussion of the solution of the problem from the section differential equations, and the question is related to linear differential equations, and it is definitely a tedious question, and it will take definitely a longer time in the examination. So that is the detailed discussion of the solution of the problem, and I wish you all the best. Thank you.